Continuing on in section 2.8, a scale model is a three-dimensional model that is similar to a three-dimensional object. The ratio of a linear measurement of a model, so like length, width, height, things like that, to the corresponding linear measurement of the actual object is always the same. So whether we compare length to length, width to width, height to height, that ratio when we simplify it down is always going to be the same. And it's called the scale of the model. So this is similar to a scale on a map, but a map is only the one dimension, where this is a three-dimensional. Example 4 here, a giant model heart is shown on page 133. The heart is the ideal size for a person who is 170 feet tall. About what size would you expect the heart of a man who is 6 feet tall to be? So here we're comparing the heart size to the person size. So I'm going to compare the heart to the person. So the heart height or size to the height of the person. And we have both a scale, this guy, and an actual man. So we could have set this up with heart and person over here and scale and man over here. It doesn't matter as long as we're consistent. So my scale heart is 14 feet. And my scale height is 170 feet. Now the man, we don't know the heart size. That's what we're trying to find. About what size would you expect the heart of a man who is 6 feet tall to be? So here, again, we can use cross products to solve this. I'm going to take 14 times 6, and 170 times x. Gives me 84 equal to 170x. X is being multiplied. I can go ahead and divide to get it by itself. And I get x is approximately 0.49 feet, which is about 6 inches, about half a foot, which seems reasonable. Think about like a heart. 6 inches seems reasonable for someone 6 foot. Maybe not for a baby, but for somebody 6 foot, half of a foot seems reasonable. Now, feel free to pause here and give this a try if you'd like. A scale model of a building is 6 inches tall. The scale of the model is 1 inch to 50 feet. How tall is the actual building? So here, my scale is 1 inch to 50 feet. So I'm comparing my model to my building. My model is 6 inches tall. We want to know how tall is the actual building. We can use cross products here. 1 times x equals 50 times 6. So x equals 300 feet. So 300 feet tall, and my label's feet because here it tells me my building is in feet. 300 feet tall for our building. Quick recap here. Proportional relationships can be used to find the missing side lengths in similar figures. Such figures can be used to measure real-world distances indirectly. And that's all I have for section 2.8.